Hi, everybody. Thank you for coming. This is a research project that we did last year, along with Emily, who couldn't be here today, and Ashley Fravel under Dr. Compton. This research project was to study the effects of 5-IAI, which is a legal alternative to MDMA or ecstasy that was developed about 28 years ago and is now circling the streets. And empirical studies we just started about 8 years ago. So this is a relatively new drug. Is there anything you want to say?
Emily, yeah, she was doing research with us when she got accepted into NOVA, and that really helped. The research that we did together helped her get into NOVA. So I just wanted to share that little thing.
Yeah, so like I said, 5-IAI was developed about 28 years ago as a legal alternative to MDMA or ecstasy. And this drug was said to affect the same neuroreceptors as ecstasy, such as serotonin, norepinephrine, and dopamine transporters. It has been reported that the potency of MDMA is double that of 5-IAI, so the effects aren't going to be as much as we observed further along in the research. But is there anything you want to say about that?
No, I think I'm good. I think we should go to the next bit.
Okay. Yeah, so there's not a lot of research on it since it's so new, and there have been reports of online blogs and such on the effects of this drug, but no real empirical study has been done on the first person effects or human trials, of course. Hallucinations following the 5-IAI ingestion have been described as relevant because 5-IAI binds to the serotonin receptors, which have been associated with the experience of hallucinations.
One thing just to note is that we saw the importance of this study because there haven't been a lot of real research on it, so we wanted to inform on that.
Yeah, so this research project concentrated on the exposure in the adolescent period of the brain composition, so we injected the rats at an adolescent age, which we'll describe later. But at the adolescent age is whenever the brain is most susceptible, whenever it's in development. So that's why we mostly concentrated on that. And also the age of drug use in schools have been reported higher since in recent years. I forget the exact number though, but cases have been getting higher. So that just really amplifies the importance of this study.
Yeah, and people think like, oh, going to a legal high alternative might be like better, but obviously it's not, or safer. And so we wanted to just touch on that too.
Yeah, a little consideration is usually given to the long-term effects, and so that's why we're doing the study. Yeah, and therefore further investigation is being done to bridge the gaps in research that's done now. And the purpose was to study specifically the long-term effects. And we used different tests to assess the different neurocognitive levels of the rats. And then also test for any lingering changes on the brain's serotonin and dopamine levels after adolescent exposure, followed by a period of abstinence. So whenever we did the test, and we'll describe this later on, whenever we did the test, it was a period after they took it, and it wasn't right after they received the drug. Oh.
It's okay. Small ear happens. We're good. We're still here.
It just crashed.
So I think it would be a more recent one. And named. What did you name it?
I think it's in here.
Thank you. It's cool because he works for media services, so that kind of helps us out a little bit. Yeah. He knows what he's doing because I wouldn't. and then put it on PowerPoint.
Yeah, I think it's here. Sorry about that. Okay, so subjects and methods. So this project consisted of 16 long Evans rats, 35 days of age, because this is considered the mid-adolescence period of rat development at the beginning of drug exposure. All rats received a total of 13 injections of 5-IAI of 20 milligrams per kilogram of their body weight, or a corresponding injection of isotonic saline, all from the prenatal day of 35 to 59, with injections spaced at 48-hour intervals. And this was double-blind study, so we didn't know which rats were injected with the saline or the 5-IAI, so to get rid of any bias that we might have going into it. Yeah.
So something that was cool about the double-blind study is in the beginning, like while we were doing it, we didn't know which ones, so we would like have to analyze the rats, and we would take notes on each of them, and we would try to guess which ones based on their behavior, which was super interesting. And one of the things that we used was the Morris water maze. I don't know, does anyone know what that is? Okay, it is like a huge tub of water.
And there'll be a video on it later so you can see.
And it has like quadrants, like north, like tape with north, south, east, and west. And we put water in the tub, and we had like a platform that they could crawl on. And we used non-toxic paint so they couldn't really see around. And so for each trial, we would drop one rat in and do a test, and then keep the quadrant in the same place for the beginning.
Yeah, and we'll talk about that more later on.
Okay.
I think next is a video.
So this one is a rat that was on 5-IAI.
And it's also going to compare it to a saline injected rat. All right, let's hope this works. With some pretty cool music.
Okay, we tried to get rid of Dr. Compton insisted on the music. We like it though. Quiet and slow. I think this one's X16, maybe. It's my favorite.
So you can see completely missed of platform. And also, the rats get really anxious in the pool, and they tend to poop.
Just for one.
Yeah, you'll probably see that.
There you
Yeah.
go. There, he found the platform. Took a while, right? Watch the next one.
This is a rat that was injected with saline.
And that was good. Yeah, so you could tell it was probably easy for us to start to see which rats were injected with saline and which weren't. One of the reasons we inject them with saline instead of not doing anything, just so there can't be any other circumstances like people blaming the needle, or so that's why we have both.
Yeah, so there were other procedures that we did as well before the Morris water maze. We did a general assessment of activity and exploration, where, would you like to describe that? Because you were there,
Yeah.
I wasn't.
Okay, so
This is the checkerboard one.
okay, so we had a little box and it had like a checkerboard in it, and we would drop a rat in gently because we love animals. We would put a rat in, and we would count the number of times it crossed each quadrant. I think there was like 9 quadrants, and how many times it lifted on its hind legs to get out, and that's how we were able to test their behavior in that. There was another one called step down passive avoidance, a standard operant chamber with a stainless steel electrified grid floor was used to assess passive avoidance conditioning. Located in the center of the floor, the chamber held a platform, and if they got off of the platform, then they would get a small shock. The shock was much less than a battery, like a regular double-ring battery.
Yeah,
So it was
It's a 4 milliamp shock, which is very small compared to a 9 volt, because that is 400 milliamps, just in comparison, so there's no harm done to the rats.
yeah, just scared them all.
Yeah, so this is just more describing the Morris water maze. There was a couple tasks that we did with it. Some of the tasks we did that we'll describe later, the platform was submerged in the water. Sometimes the platform was not submerged. And then in other tests, we would move the platform around to see if they could remember what quadrant it was in and whatnot. But this is what it looked like. And Ashley was saying they had different sides, the north, south, east, and west, that we would just indicate how many times the rat crossed the quadrants, which we considered errors. And the more quadrants it crossed looking for the platform, the more errors it was said to do.
That helped us determine which ones were injected with 5-IAI as
Right.
blind participants.
So these are two of the tests that we did. Simple cued place learning. Basically, we ran a series of tests where we would have the platform in one place whenever it was not submerged, and we would drop them in different parts of the tub and see how fast the rat would get there. And then also we ran the same thing, or the same test, but with the platform submerged. This is to see if there was any differences. And I'm kind of blazing through this now. The last phase of testing, learning set acquisition, required the animals to learn new locations of the escape platform daily on each of 5 consecutive days. Yeah, we would move the platform around. And all animals would receive 4 consecutive trials per day. And here are the results. So the general activity, what Ashley was talking about with the checkerboard, and we see how many times it would go up on its hind legs and cross the quadrants. There was significantly higher the rearing behavior in the 5-IAI rats was significantly higher than the control animals, with a mean being 17 with a standard deviation of 8.28. And with the control rats with a mean of 8 times with a standard deviation of about 8. And then the set down of passive avoidance with the avoidance of the shock, there was no difference between them. Escape latencies and quadrant crossings decreased as a function of experience both with trials and across the 2-day test period. However, no drug association effect was found. Using a visible escape platform, we included this assessment phase to determine if non-associative influence, such as general swimming ability and non-declarative memory ability, could influence performance during this spatial place at the learning set tasks. And following the cued place learning, 2 phases of the protocol with tests of spatial reference memory that varied in difficulty were considered. Here, the Morris water maze tasks involved learning at the location of the submerged platform that remained constant across all trials within a given phase of the experiment. A latter, more difficult and hard version of the place learning task was also included, since it is considered more sensitive to spatial learning memory impairments following adolescent drug exposure. And as with the cued place learning data, escape latencies decreased as a function of experience both across blocks of trials and across the 2-day test period. And we'll go into the numbers later. With a spatial water maze task following the cued place learning, 2 phases of the protocol with tests of spatial reference. I'm sorry, I'm reading the wrong one. Examination of data revealed that an effect of the drug group suggesting differences in escape latencies as a function of drug condition that remained across the assessment period. On probe trials, with the exception of the 5th day, time spent in the formally correct escape quadrant declined across days, but the control animals spent significantly more time in this quadrant than the 5-IAI. So basically, whenever we moved the platform around, the control group tended to go back to where the platform was originally, and the ones that were affected with 5-IAI wandered around more. And I have 5 more minutes, so I'm going to try to blaze through. So this was some of the data we had for the spatial learning. So this is a graph about the data we had on the mean escape latency. As you can see, trial 1 was about the same for both groups, but the second trial, the control group, performed much better than the group of 5II, or that was affected with 5II. Is there anything you want to say about that? Okay. And
I just want to get to the last part.
yeah, and this was the mean number of additional quadrant cross or errors, and the results were they correlated, but they weren't significant with a p-value of 0.053 because the alpha level we set was 0.05 and it didn't quite cross it. So we couldn't reject the null hypothesis. Also, the neurochemical analysis of the brain was done after using, I think it was HPLC, an HPLC analysis, and the serotonin and dopamine levels, there was no significant difference between the 5AI and the saline. And this was after the drug exposure. So I'm going to go through this part because there's a lot more that we have. Basically, so I'm going to summarize all of this. Further research can be done to, let me go to first. Okay, so further research can be done to continue the discussion, which we plan on doing further. And this is a section that I actually wanted to put in at the end as an encouragement to other students looking to get into research.
So we just wanted to share quickly why research is important as undergrads and how it's impacted us. And Dr. Compton's not here, but we just wanted to thank him for giving us this opportunity. It's such a great opportunity, and we have these resources because of PBA. We have a small school, so yeah, thank you.
We don't really have much time.
How much time do we have? 3 minutes, that's cool.
Do we want to do questions? Yes.
Okay.
So there was a question. So at the end there where you had non-significance, you gave the p-values. Perhaps in the future you could give the p-values of what the significance was when you compare the two means.
Oh, okay.
So I assume that since you said they were significant, there would have been a p-value associated with that.
Right. We included it with the one that was not significant to show you what it was.
Right.
But I didn't include it with the, it should be the opposite.
It should be the opposite.
Yeah.
Right. So good for future.
Okay, thank
The
you.
other way around.
Yes?
Just quick, for understanding the purpose, what would you guys foresee the real world application for this study?
It's to bring awareness to just because a drug might be legal or not like Schedule 1, 2, or 3, that it could still be damaging. And it's more to prevent awareness of the long-term effects of these drugs. Yes.
Okay, in the beginning, in your materials and methods, you said that you gave them 13 injections each?
Over a period of a couple weeks.
Oh,
Yeah, it was like about a month.
that might have been good to have presented at that time.
Okay.
Well, it is, I'll
Yeah.
wait a second, I'll come back.
Thank you.
In fact, I'll just go back on the slide to research and methods. Right. So it was over a period of 48-hour intervals from
Oh, yeah.
35 days and 59 days.
Sorry, I missed that part.
That's okay.
So you did the post-analysis, you were actually looking at their brains and you didn't notice any difference? Is that
Yeah, there's no neurochemical difference.
how many days did the test cover?
Yeah, how many
It
days
was-
was,
It was like about a total of 40 hours and about 2 months. That week when we did tests, yeah.
okay. And you said you changed the platform positions a lot, so how
Yes.
many replicates of each platform position
We
did you
did
do?
10.
10 of each,
Yes.
of each round?
Yeah.
Wow, that's good.
It was a lot of
Yeah.
a lot of hours.
Okay,
It was
and
great.
what test did you use to get your p-values?
We used SPSS. I forget the
That's
exact.
what I used.
I forget exactly what we did, but yeah.
Cool. thank you guys for, if you have any more questions, we're here, but quick thing, I just want to encourage people to participate in undergrad research. We didn't get to that portion of it, but it really, it adds to your resume when applying to grad school, and I just think it's really important.
It's a good experience.
It's a great experience.
To add the
thank you guys
conversation, so.
for coming.
Yeah.
Thanks, guys.